Today, we are going to program an ESP32 to operate a 16-channel relay with Alexa without any third-party apps.
Hi everyone, and welcome to Building from Scratch. And this is part 2 of the home automation system. Today we're going to be taking an ESP32 and programming it for 16 relays and to work with Alexa without any third-party apps. Now, we may be doing the program for 16 relays, but you can do anywhere between 1 to however many you need, and however many you can actually operate with your ESP. So let's go ahead and let Joey do his work. We'll talk to you a little bit later. Thanks. Bye.
Let's take a look at the ESP32s. These are powerful yet low-energy microprocessors. There are many designs. Some are a single core, and some, like the one we will be using, are dual core. They also have Bluetooth built into them. They have 4 megabytes of RAM. Now there are 2 types. One has 30 pins, and the developmental one has 38 pins. We will be using the developmental one for this project. Both are programmed the same. What we are going to need to use the ESP32s. First of all, we are going to need to get the driver for this chip. If you look here, it has a CP210 chip. The CP210X USB to UART bridge virtual COM port. VCP drivers are required for device operation as a virtual COM port to facilitate host communication with CP210X products. You need to go to this page here. Links will be placed in the description. Click on the Downloads tab. Scroll down to your operating system and download it. Go to where you saved the file, unpack it and install it. As with the ESP8266, open Device Manager. Open the port folder and plug your ESP32 in. You will see a new COM port. Again, remember it, you are going to need it later. If you didn't watch the last video, you will need the ESP Alexa library. The link is below. You will go to this website. Click on the code and download the zip. Place it in a spot where you can find it. Open your Arduino IDE and click on Sketch. Go to Libraries and click on Add Zip Libraries. Go to where you saved the library and click on the file. Arduino will tell you that it has been installed. Click the link in the description that says Board Manager. Copy the web address that you see. Go back to Arduino and click on Files. Now click on Preferences. You will see this box, Additional Board Manager. Take the web address you copied from the page and paste it in this box. If you have an address in this box already, just add a comma and paste it after the comma. Close the box and click on Tools. Go to Boards and click on Boards Manager. This box will open. In the search box you will type ESP32. You will see this pop up. Install it. Now close it. Again, click Tools and go down to Boards. You will see a new folder called ESP32 Arduino. In this folder you will find a list of ESP32 boards. For my board, I selected the Node MCU32S. Once you have selected your board, you need to click Tools and go to Port. select the port number you saw in the device manager. Now this is how you will get Alexa to find more than 10 devices. Go into your libraries, find the ESP Alexa folder and open it. There is a file called espalexa.h. Using a text editor, open the file. Look for this line here. You can see that it is limiting Alexa to 10 devices. You need to change that number to the number of devices you are going to be using. Save and close the file. Go to this link and click on the code and download the zip. Place it in your sketch folder. Unpack the file. Open the folder called ESP32. In there you should find the Blink test folder. I had to write this as there was no Blink test for the ESP32. Open the Arduino file. And upload it to your ESP32. If everything is good, you should see this. The ESP32 code for Alexa and 16 relays. Go back to the ESP folder and you will see a folder that says 16_channel_ with _ESP32_ and _Alexa. Open it and load the Arduino file that you see. Let's go through the code and see the difference between this and the 8 relays for the ESP8266. If you look closely, you will see that it is exactly like the ESP8266 sketch. First it looks to see what type of chip you are programming, and then decides which Wi-Fi file to use. Next we define the 16 relays and the GPIOs for each relay. You can add or lessen the number of relays shown here to meet your needs. Like last time, this is the callback function that is set up for each relay and device name. Next, put in your SSID name and password for your Wi-Fi. Here we are setting up strings for the device names you want Alexa to use. As with when we define the relays, you can add or lessen the number as needed. Change the device names to whatever you want. In the setup we set the baud rate to 115,200 for the serial port. After that, we set all of the relays we are using to output only. Here the program is telling Alexa the device names, and matching them to their callback function. Here it starts the loop function. I suggest between 5 and 10. Anything smaller will cause you to only find part of your devices, if any at all. This is where the callback function comes into play. Before the device names were linked to the callback. Here the callback names are basically linked to the relays. I changed the digital rights that turn the lights on to low. The reason for this is that when you have it low, it actually sends a signal to switch the relay on, and vice versa when you send a high. Just remember that if you change the callback names, you will have to change them here too. The results. For a better example, this is our modified sketch for the houseboat automation. First you will see that we renamed the callback to help keep track of what devices go with what callback. Here you see the device names we are using. Here we added digital write to all of the pins to turn all of the pins off. And last you can see we changed the callback names here to reflect the new names we gave them earlier. Let's upload the program and see what happens. Now let's do a device discovery with the Alexa app. This will take 45 seconds, so we are going to speed up the video. I know the focus makes it a little hard to see, but it is showing 16 devices found. Let's test it out with the app. It works great except that this relay here, and this one here are blown out. Well, that is it for now. Tune in next time when we add 4 liquid crystal displays, and AI2C multiplexer. The multiplexer is to show you how to use multi-I2C devices that have the same digital address. Remember to subscribe and like the channel. Also, please check out our GoFundMe campaign. Until next time, stay safe, stay healthy, and stay happy. Here is a list of contributes of one sort or another. Get your name on it.